When talking about modern symmetric key ciphers, first let's discuss the difference between traditional and modern ciphers. The traditional symmetric key ciphers are character-oriented ciphers. With the advent of the computer, we need bit-oriented ciphers, which are the modern ciphers. This is because the information to be encrypted is not just text, it can also consist of numbers, graphics, audio, and video data. A modern block cipher is a cipher that encrypts an n-bit block of plain text and decrypts an n-bit block of ciphertext. For encryption or decryption, a modern block cipher facilitates a k-bit key. The decryption algorithm needs to be the inverse of the encryption algorithm, and both operations must use the same secret key. A modern block cipher can be designed to act as a substitution cipher or a transposition cipher. A substitution cipher is a type of encryption where symbols are replaced by others. A transposition cipher is a method of encryption that scrambles the positions of symbols without changing the symbols themselves. A modern block cipher is designed as a substitution cipher, in order to be resistant to exhaustive search attacks. The transposition cipher only transposes bits without changing their values. So, it can be modeled as an n-object permutation with a set of n-factorial permutation tables in which the key defines which table is used by the sender and receiver. We need to have n possible keys, so the key should have log2n bits. The set of permutation tables has 3 factorial equals 6 elements. The key should be log2 equals 3 bits long. The substitution cipher substitutes bits. We can model it as a permutation if we can decode the input and encode the output. Decoding is transforming an n-bit integer into a 2 to the power of n-bit string with only a single 1 and 2 to the power of n, ones and zeros. Encoding is the reverse process. In this example, the number of elements is 8 equals 40,320 and the key equals 16 bits. A p-box, permutation box, parallels the traditional transposition cipher for characters. It transposes bits. There are 3 types of p-boxes. A straight p-box is a p-box with n inputs and m outputs where the number of outputs is the same as the number of inputs. A compression p-box has a number of outputs that is less than the number of inputs. An expansion p-box has a number of outputs that is greater than the number of inputs. A straight p-box is invertible, but compression and expansion p-boxes are not. An S-box, substitution box, can be thought of as a miniature substitution cipher. The input to an S-box could be an n-bit word, but the output can be an m-bit word, where they are not necessarily the same. In a linear S-box, the relationship between the inputs and outputs can be represented as a set of equations. However, a nonlinear S-box cannot have these relations for every output. Exclusive OR compares 2 input bits and generates 1 output bit. The encryption algorithm is based on applying an exclusive OR mask using plain text and a key. Using the same key to the ciphertext outputs the original plain text. Another component found in some modern block ciphers is the circular shift operation. The figure shows the circular shifting of an 8-bit word to the left or right. The swap operation is a special case of the circular shift operation where k equals n divided by 2. This means this operation is valid only if n is an even number. Because left shifting is the same as right shifting, this component is self-invertible. The split operation splits an n-bit word in the middle, creating 2 equal-length words. The combine operation concatenates 2 equal-length words to create an n-bit word. Product ciphers are complex ciphers combining substitution, permutation, and other components. The main idea of diffusion is to hide the relationship between plain text and ciphertext. On the other hand, confusion hides the relationship between the ciphertext and the key. A Feistel cipher can have 3 types of components: self-invertible, invertible, and non-invertible. A Feistel cipher combines all non-invertible elements in a unit and uses the same unit in the encryption and decryption algorithms. Non-Feistel cipher uses only invertible components. A component in the encryption cipher has the corresponding components in the decryption cipher. Linear cryptanalysis always works on a single bit, 1 bit at a time. In linear cryptanalysis, ciphertext attack is a very big disadvantage. We can easily figure out the linear relationship between some plain text bits, ciphertext bits, and unknown key bits. Differential cryptanalysis can work on multiple bits at a time. In this case, the plaintext attack is a very big disadvantage. We get clues about some critical bits, reducing the need for an extensive search. A stream cipher is a method of encrypting text in which a cryptographic key and algorithm are applied to each binary digit in a data stream, one bit at a time. Synchronous ciphers have the advantage that key stream can be pre-computed before plaintext or ciphertext is provided, often with parallelism. They have the disadvantage of ciphertext malleability and so will need to be combined with some form of message authentication. Synchronous ciphers are also deterministic constructions with a finite number of possible states and so will eventually cycle. Asynchronous ciphers are largely serial in the encryption process and the key stream can only be computed once the plaintext or ciphertext is provided. Changing the ciphertext changes subsequent key streams and so there is considerably less malleability and a degree of message authentication. They also allow easy synchronization at any point in transmission as the receiver can infer the key stream after an initial run-up of cipher bits, self-synchronization. Implementing stream ciphers. For a nonlinear feedback shift register, the input bit is a nonlinear function of its previous state, where f is the nonlinear feedback function. They are components of modern stream ciphers, especially in smart card applications. Also, more resistant to cryptanalytic attacks. For the linear feedback shift register, the input bit is a linear function of its previous state. The input bit is driven by the XOR of some bits of the overall shift register value. The application generates pseudo-random numbers,